Good morning, guys. How lucky you guys get me 2 lessons in a row. I know. I feel the love. Thank you so much. So, today we're going to move on a little bit. We're still technically in our quadratics unit, but this is kind of like pretty much the end of it. So, what we're doing today is a little bit of a difficult lesson. I'm not going to lie to you guys. It's called Little Equations, all right? Today, there's going to be very little math. It's more about isolating a variable and setting the rest of the equation equal to that variable. All right, we do this a lot when we set equations equal to y or equal to x. That's a literal equation. All right, so we do have some experience doing this, but still, it is a little bit of a difficult lesson. So, as always, if you're having any trouble, if you're not sure, I'll be on at 1:30 for our office hours. Please sign on. Let me know what you're having trouble with. I'll help you out with anything. Okay? So, here's our new agenda. Before I tell you to pause and try it, what I suggest, you could do one of two ways. You could either factor or try to get x by itself. I wouldn't factor today. I know you see x squared, and we've been doing that, and you can if you want to, but I would try to get x by itself. Add, subtract, multiply, divide, and see what you come up with, all right? So why don't you pause now and give it a try. All right, hopefully by now you paused, you gave it a try, you saw what you could do, what you couldn't do. We're going to do it together right now. Any questions, I'll talk to you guys later about it, all right? So first thing you're going to do is subtract 1 from both sides. Remember I told you, try to get x by itself. All right, so that gives you 336. Then you're going to divide both sides by 7. All right. Sorry, give me 1 second. My dog is going to be making noise, and I don't want to hear it. Hold on, guys. Sorry about that, ladies and gentlemen. Okay. So, like I said, our next part now is that we're going to divide both sides by 7, all right? So divide both sides by 7. So that gives me x squared equals, 48. All right, and now we want x by itself. Remember what you always do to get x by itself? Square root both sides. So we get x is equal to the square root of 48. 48 cannot be square rooted. All right, cannot be square rooted. So we do have to break it down. So 48 actually breaks down to 16 and 3. And take the square root of 16, which is 4. So our final answer here is 4 radical 3. Oh, I'm sorry. You see, even your genius teacher, Mr. S, makes a mistake. This should actually be x equals plus or minus 4 radical 3. Sorry about my mistake. Again, even me, as wise as I am, makes mistakes sometimes, all right? So that's how we get to, and that's really our goal today. Add, subtract, multiply, divide, square root, whatever we can do to get our variable that we're looking for by itself, all right? So, little equation is an equation with 2 or more variables. We can isolate any variable we want to, okay? And remember, to get rid of a square by square rooting. So those are 3 tips. That's 2 tips just to remember, and the definition of little equations. So, let's look at this equation for example. The equation for the volume of a cylinder is V equals pi r squared times h. So they want to know what is the positive value for r. So that means they want r to be positive. What is the positive value for r in terms of V and h? So essentially what they want is r by itself. How do you get r alone? All right. So we have V equals pi r squared h. Okay? Now remember, guys, when everything is next to each other, if you don't see a plus or a minus sign, that means that all of these are being multiplied. All right. So if I want r by itself, and I know everything's being multiplied on the right side, I'm going to do the opposite of multiplication. I'm going to divide. I'm going to divide by both terms because I can do that if it's all being multiplied. All right. I don't see a parenthesis, so I'm not confined to any restrictions here. Okay. So I divide both sides by pi h. It cancels out on the right side. So now I have v over pi h equals r squared. I want to get r alone. I don't want r with anything. So I'm going to square root both sides. So when I do that, I have the square root of v over pi h is equal to r. That's all I have to do, guys. I just have to find a way to get the variable by itself. All right. So again, up here, I notice that these three terms are being multiplied. So all I did was divide by the two terms that I'm not solving for. I'm solving for r. So I want to leave r where it is. I want to get rid of everything around r. So I divided by pi and h. I do that to both sides. And then I would need to get rid of the square here, so I square root. Since I have nothing to break down on the left side, I leave the square root sign over v and pi h. And on the right side, they cancel out, which leaves me with just r, which is what I'm trying to do. Okay? So that's your first one. All right, your second problem. It says the distance of a free-falling object has traveled can be modeled by the equation d is equal to 1/2 at squared, where a is the acceleration due to gravity and t is the amount of time the object has fallen. What is t in terms of AD? So they want t by itself, all right? They want t to be isolated. So what we're going to do here is we have, let's rewrite it, d equals 1/2 at squared. We want to get t by itself. Once again, these three terms are being multiplied. There is no addition, no subtraction sign. So if they're being multiplied, I'm just going to divide by 1/2 a. Actually, that's not true. Sorry, let me redo that because that's going to give you a confusing answer. The first thing I actually want to do is I want to get rid of that 1/2. So I'm going to do the opposite because I want to get rid of the fraction. So I'm going to multiply both sides by 2. So when I multiply both sides by 2, the 2 and the 1/2 cancel out, and that's what I'm looking for. Actually, let me move all this down for you guys. I'm sorry, I didn't realize how much up here it was. There we go. So the 1/2 and the 2, they cancel out, okay? And that's my goal there, to cancel those two things out. Again, you could divide by 1/2, but then you would have to remember to flip it. And some of you might forget that, and that's a little confusing, so why do that? So now I have 2d equals at squared. Okay? Now again, I gotta get t by itself, so I'm going to divide both sides by a. So now I have 2d divided by a equals t squared. I need to get t alone, so I square root, and my final answer is the square root of 2d over a is equal to t. Okay? So again, just to reiterate, I multiply by 2 on both sides because I want to get rid of the 1/2. You can divide, but if you divide, you have to remember to flip the 1/2 over and do its reciprocal. All right? So it's just easier, again, to multiply by 2. So I have 2d equals at squared. I divide both sides by a. I have 2d over a equals t squared. I want to cancel out the square, so I square root both sides, and that's my final answer there. All right? All right, next problem. So now I have k is equal to am plus 3mx, and they want to express the value of m in terms of a, k, and x. So they want you to solve for m. That's what they're asking for, solve for m. Now we have a little issue here. And the issue is that I see two m's, right? I have an m right here, and I have an m right here. So if I have two m's, what that means is that I have to factor out, or I have to figure out a way to get m by itself. All right? So I'm going to actually factor out the m. I'm going to do a GCF so I can have just one m by itself. All right? So if that's the case, what I'm going to have here, is k is equal to m times a plus 3x. Okay? Again, that's isolating the m, which is what we want to do. All right? Guys, give me 1 second. I'm sorry, just my dog is getting a little crazy. Doesn't matter. I'll split it. Okay. Sorry about that, guys. My dog's been getting a little crazy tonight. All right, so we have k equals m times a plus 3x. All right, again, the reason I factored at the end, what I did is I GCF'd it. All right, so I'm going to do that over here. Imagine I have am and 3mx. The m is our common factor, so if I pull it out and I divide both sides by m, I'm left with a plus 3x, all right? Now, again, I got to get m by itself. Since it's multiplication, I'm going to divide by a plus 3x and a plus 3x. And I'm going to have k over a plus 3x is equal to m. And that was a nice, easy one. Again, you just have to remember your factoring there, all right? That's really all that you have to remember there. Other than that, it was a nice, easy method for you guys, all right? All right. I believe this is the last one. Yes, it is. All right. So this is going to be our last problem that I'm doing with you. Again, if anything's been confusing, I know this is a confusing topic. So if anything's been confusing, please come later to live office hours and I'll help you out. This is going to be the hardest problem we do, so really pay attention here. It's saying solve the equation for x in terms of a. So solve the equation for x in terms of a. Now before we do anything, let's see what we have in front of us. And we have to follow our order of operations anyway, because some of you might want to factor, but we can't factor yet, because that a of x, this first one right here, it's in a parenthesis. So we can't factor in if we wanted to, okay? So I do see 2 x's, but let's see what we can do first. So the first thing I hope all of you instinctively want to do is distribute. I hope you all see that we have a 4 times ax plus 3 here. We got to get rid of the parenthesis, so we got to distribute, all right? So that's going to be the first thing we do. We're going to distribute. So we have 4ax plus 12 minus 3ax is equal to 25 plus 3a. Okay? Now, here, what I see is I see 2 like terms. So I'm going to combine my like terms. They both have the same variable, raised to the same exponents. So I'm going to combine my 2 like terms here. So I'm going to have 4 minus 3, which is just ax. If you want to put the 1 in front, of course you can, but you do not have to. So ax plus 12 equals 25 plus 3a. Okay? Now let's get x by itself. That's my goal here, get x alone. So I'm going to subtract 12 from both sides. I can do 25 minus 12, which is 13, plus 3a. And then my last step to get x alone. Sorry guys, give me 1 second. There we go. My last step to get x alone is just divide both sides by a. So x is equal to 13 plus 3a divided by a. Or if you really want to break it down, x is equal to 13a plus 3, because the a's would cancel out in that situation. So whichever answer you want to put, both answers are fine. All right. But make sure, again, x is alone. That's your goal here, to get x isolated. All right, so we distributed. Got 4ax plus 12 minus 3ax. We combine our like terms and got just ax. Or again, if you want to put 1 in front, you can. That's an a, not a 9. Just in case some of you want to be smart Alex about it. That's an a. And then you subtract 12 from both sides. 25 minus 12 is 13. 12 minus 12 cancel out. And then we divide by a to get x alone. You can do 13 plus 3a over a, or just 13 over a plus 3. All right? And then here's your group work. This is your last thing. If you need any help with it, please call me later. Please come on Google Hangouts later. But this is the end of it. All right, make sure we submit this and anything we have. All right. Have a great day, guys. I'll see you guys soon.